So now what we're going to do is we're going to do some vocabulary, key terms, things that you need to remember from this, things that I want to point out that maybe you've already started to notice, but I really need you now to kind of think more deeply about what it is that we're learning here. The very first thing that I want you to do is think about the word square. So what do we know about a square? We know that a square is four-sided. You always tell me the same things. You know that it's got four equal sides. But now what we're going to do is we're going to label the side lengths as n and n. And if I were to find the area of that square, the area of that square would be n times n. And we know that this has to do with n squared because n times n is n squared. That's what we're doing here. So moving on, the other thing that I want to point out is we've already been working with exponents, but now we're going to be talking about a square term. So if you think about a square and this of n squared, again I go back to my square of n times n, which we know is n squared when I find my area. But then any time I have an exponent of 2. This means a square term. So anything with an exponent of 2 means I've got a square term. Well, we're going to build on that. So as you always tell me, if I draw a square, and if I were going to name this properly in geometrical terms, I would call this a quadrilateral. Well, quad means four-sided, quadratic means I'm going to be dealing with a squared term. That's where all this comes from. Quadratic is four-sided. It's a square. We're going to be dealing with squared terms in quadratics. So the last piece is the word quadratic expression. And when I am talking about a quadratic expression, we are talking about a form of ax squared plus bx plus c. This is the standard form of a quadratic, but this is the piece we are looking at. Right there, that square, this 2, is going to tell me that I've got a quadratic. Okay, so right there, this is a quadratic because the exponent is 2. The last piece that we're going to talk about is what do we notice? So I want you right now to take an opportunity and everything that we've talked about in this lesson, I want you to notice and circle or shade what you see, then go ahead and make a table to help us recognize a pattern if you haven't seen it yet. So what did I notice? I noticed that I had a square. I had a 1 by 1, step 1. Step 2, I had a 2 by 2. Step 3, I had a 3 by 3 square. I also noticed that every single time I seem to have a single square sitting right above as an arm above the other square. And I could draw my 4 by 4 the same way and a 5 by 5 the same way. So I could go ahead and I can now take a look at my table. Step 1 has got 2 squares. Step 2 has got 5 squares. Step 3 has got 10. Step 4, 17. Notice, what did I do when I moved from 2 to 5? I added 3, then I added 5, then I added 7. This is increasing. Therefore, I know, based on my vocabulary terms up on top here, that it's quadratic. Last piece. What is your understanding so far of what a quadratic expression or relationship is or is not? So go ahead and just jot down some things, and then I'm going to show you my notes so you could copy them down. So let's talk about what it is not. We know that a quadratic expression is not adding the same amount each time. I know it's not linear. Second thing, I know it's not exponential. I'm not multiplying by the same amount each time. What else do I know? That when I graphed it, that the graph was a curve, but I realized the rule is not exponential. I know it's not exponential because I'm not multiplying by the same amount each time. I also know, what do I need to look for? I need to look for squares. I need to look for things that can replicate or be a square within my patterns. I'm going to know that I'm going to be adding something to the square. Or maybe I'm subtracting, but in this lesson that we just did, we were adding 1 or adding 2 additional squares to the original square. I also know that an exponential rule is y is equal to ab to the power of x. This is from Unit 5. I also know that my x is my input. My input, if you remember, was always my independent variable. It was time, oftentimes in exponential functions. Well, in this case, I am not doing time in a quadratic. I'm not multiplying up here. My exponent is not x. What is my exponent that we've seen over and over again in this lesson? We've noticed that it is always 2. And I've noticed that there is a relationship between the step number and the number of squares. Squares. I'm talking about the number of squares in the square here. So n squared. I took n squared plus 1, n squared plus 2. This is my square that I'm talking about. These are the additional squares that I added on to my square. These are all examples of quadratic expressions.